Hello and welcome. In this brief video, we're going to take a look at a technique called rationalizing the denominator, where if you just have a fraction with a square root or some nth principal root in the denominator, we'll see if we can use this technique so that we end up with an integer in the denominator, which is basically something that's a little bit simpler to look at. Let's try a couple examples here. First example is what to do if you just have a square root in the denominator. So let's say that we have some sort of fraction of the form a over the square root of b, and we know that b has to be positive because it can't equal 0 in the denominator, and we can't take the square root of a negative. Okay, well, it's never easy to think about a fraction with a square root of something in the bottom when it's easier to think about things like halves and quarters and thirds. So what we can do is we can take that square root of b and use that as a factor that we multiply the numerator by as well as the denominator. So that way we end up with an equivalent fraction. As a result, we'll end up with a root b on the top. And on the bottom, you notice it's root b times root b, which is root b squared. Now, b is a positive number, so we take the square root of it, and then you square that back, and they should cancel each other out. That leaves you with a root b over b. And that's a lot easier to think about. This is an example, and this will come up a lot when we're looking at trigonometric ratios later on. 1 over root 2, if you were to multiply by root 2 over root 2, rationalizing the denominator, on the top we'll end up with a square root of 2, on the bottom we'll end up with 2. And that's a little easier to think about, because root 2, you can start to understand what that number is, and then we're simply dividing that number by 2. It's a half of the value. In fact, you could write that as 1/2 root 2. That makes the fraction a little bit easier to think about. Now, what about if I have the nth root of b in the denominator? If I have a, let's say, over the cubed root of b as just an example. Now, I don't need to have b be positive, but I do have to make sure that b is not equal to 0. It is okay to take the cube root of a negative number. Well, it's implied here that I've got a single factor of cubed root of b, and if I want to have a cube root of b get canceled out through some other multiplication, I need to have a total of 3 factors of the cube root of b. So I'm going to multiply bottom here by cube root of b squared, and I'll do the same thing in the numerator as well. So as a result, I'll have 3 factors of cube root b on the bottom, and that's the same thing as cube root b cubed. That's how I can cancel out the cube root in the denominator. Now on the top, that means I'm left with a times the cubed root of b all squared. But it does mean that I can get a nice simple denominator in this case, which is just b. And I'll be left with a cubed root squared in the numerator. You can use this technique to try to simplify fractions a little bit. It helps when you don't have a root in the denominator to try to understand how you're just simply taking a fraction of a root or radical of some kind. And we'll look at rationalizing the denominator in other fashions in the later section when we have addition and subtraction combined in there as well. Yeah, well, thanks for watching, and I'll see you in the next video.